So for our last examples, again, we want to start by picking out which theorem we need. So we're asked to express each sum or difference as a product of sines or cosines. So my part A says sine of 4 theta minus sine of 6 theta. So I would have sine in both my terms, and I'm subtracting, which means I'm going to use this second formula down here. And just like in the previous examples, we want to identify alpha and beta. Alpha is our first angle, so 4 theta. Beta is our second angle, or 6 theta. And then plug and chug. So using that second formula, we get 2 times sine of alpha minus beta, so 4 theta minus 6 theta, all over 2, times cosine alpha plus beta, so 4 theta plus 6 theta, all over 2. So just like in the last examples, we're going to continue simplifying this by simplifying the angles. So the 2 stays out front, and I've got sine 4 theta minus 6 theta is negative 2 theta, still over 2. Then I have cosine 4 theta plus 6 theta is 10 theta, again all over 2. Now this next part you can do in either 1 or 2 steps. You can go ahead and simplify the divide by 2 for each angle and then take care of any negatives, or you can do it all at once, whatever you're comfortable with. I'm going to go ahead and combine them into one step. If I look at my first angle here, 2 theta over 2, my 2's are going to cancel, so I'm left with just negative theta inside my angle. And we know it's never simplified with a negative angle. Since sine is odd, we're going to go ahead and pull that negative out front. So I can simplify my first portion by saying negative 2 sine of theta. Now if I look at my second angle here, cosine of 10 theta over 2, 10 over 2 reduces to 5 theta. So I'm left with cosine of 5 theta. And there in blue is my final solution, negative 2 sine theta, cosine 5 theta. We've taken a difference, subtracting 2 sine functions, and rewritten it as a multiplication using both sine and cosine. So we'll practice our final one here. Part B, cosine of 2 theta plus cosine of 8 theta. Again, big thing here, make sure you're identifying the correct theorem to use. We're going to use this third formula down here since I've got cosine for both terms and I'm adding. Alpha is giving me my first angle of 2 theta, and beta is my second angle of 8 theta. So when I plug it into my formula, I get 2 times cosine alpha plus beta, 2 theta plus 8 theta, all over 2. Then times cosine of alpha minus beta over 2. 2 theta minus 8 theta, all over 2. And just like we have been doing, we're going to continue simplifying in that same fashion. The 2 stays out front. Cosine 2 theta plus 8 theta, we're getting that 10 theta, just like we had in the last example, over 2. And cosine 2 theta minus 8 theta is going to give us a negative 6 theta over 2. And again, do this in as many steps as necessary. My first angle, 10 theta over 2 theta, is going to reduce to just 5 theta. And my second angle here, negative 6 over 2, we're going to reduce to 3. 6 over 2 is 3, but we have that negative. However, this time we have a cosine with a negative angle. Cosine is an even function, and cosine of any negative angle is the same thing as cosine of a positive angle. So that can actually just go away. So my final reduced form, 2 cosine of 5 theta times cosine of 3 theta. No negatives at all in that final answer. So again, we didn't do a whole lot with working with these in terms of using them in an identity. That's something that's a little bit higher level. At this stage, I just want you to be able to practice converting from one and the other. Differences to products, or sums to products, and then products to sums or differences. If you have any questions, please let me know.